The James Webb Space Telescope has recently achieved a groundbreaking feat. Far beyond our solar system, millions of light-years away, it has detected shocking signs of life on an exoplanet. This, among a series of other intriguing discoveries, set the JWST apart from its predecessors in its quest to explore ancient cosmic mysteries and provide new opportunities to find hidden space secrets. But could life, in all its breathtaking diversity, be thriving far beyond the boundaries of our home planet? If so, what mysterious forces govern the existence of life in such distant reaches of the universe? Join us as we unravel this terrifying discovery by James Webb and explore the implications of finding signs of life at such a distant location of space. The James Webb Telescope's search for extraterrestrial life. The James Webb Space Telescope set off on its journey in 2021. Since then, it's been on this mind-blowing adventure through space, showing us some seriously shocking discoveries about the universe. Rather than solely focusing on the overall view, this telescope provides a detailed exploration of the nearby celestial objects in space. Its mission is huge, like unraveling the mysteries of how everything in the universe began way back in the day. And guess what? Lately, it's dropped a bombshell. There might be life out there beyond our little blue planet. Yeah, seriously. Scientists boldly tested the telescope by observing Earth from a considerable distance in space. They used all this data about our atmosphere and fine-tuned it. It's like the telescope pretended to be a faraway star, peeking at Earth from light years away. It wasn't just for fun, it was a big test for the telescope. The telescope's sensors went on this crazy journey into space to find signs of life. They examined substances such as methane and oxygen, which are indicators of potential life, similar to what we find on Earth. But wait, it didn't stop there. It dug even deeper, looking for signs of intelligent civilizations. It checked out things like nitrogen dioxide and chlorofluorocarbons, substances that could be left behind by really brainy beings out there. And guess what? The results were seriously mind-blowing. Now this telescope is looking at Earth from the TRAPPIST-1 star system, which is a whopping 40 light-years away. That's a huge leap for us. It's like we're getting closer to finding signs of life within this massive 40 light-year space. And it might not stop there. It could keep going and look for even terrifying secrets of aliens up to 50 light-years away from us. But hold on tight, because now we've got K2-18b entering the scene. This planet is a massive 120 light-years away in our Milky Way galaxy. And get this, it's a heavyweight champ, weighing in at a crazy 8.6 times more than our Earth. That's not just big, it's gigantic, like 2 to 3 times larger than our home sweet home. What's interesting about K2-18b isn't just its size. They call it a clean world, which means it might have all the right substances in its atmosphere, especially hydrogen. Why does that matter? Because it could mean this planet has oceans of water on its surface. Imagine that. And the best part? The telescope might just be able to scan through the Milky Way and find even the faintest signs of life on K2-18b. That's a whole new level of cosmic discovery, way beyond what we ever thought possible. And guess what? There's even more incredible discovery coming up. Unveiling dimethyl sulfide as a cosmic biosignature. When the James Webb Space Telescope turned its attention to far-off K2-18b, it shook up the whole scientific world. Among the expected substances like carbon dioxide and methane in the air, a real surprise popped up. Dimethyl sulfide, or DMS. Sounds fancy, right? Well, on Earth, this molecule only comes from living things, like tiny phytoplankton in the ocean. Finding DMs on an exoplanet? That's a first. See, scientists usually hunt for signs of life on rocky planets, but now they're eyeing Hycean worlds, places swimming in the water and wrapped in hydrogen. It's a whole new game, challenging the idea that only planets like Earth can host life. In this diverse universe, we're getting pumped to discover life beyond what we've known. But hold your horses, because we're just starting with K2-18b. Scientists got their first batch of info from the JWST, and they're itching for more. Confirming DMs and the idea of life on this distant planet needs extra data and more snooping around. Finding signs of life out there is tough. We know our stuff here on Earth, but space signals, they're a puzzle. It's tricky, because even things we're sure about, like oxygen, might come from totally different sources out there. On Earth, plants and algae make oxygen, but somewhere else? It could be from non-life things. Figuring out these life hints is like teasing apart a complicated cosmic puzzle. But hey, this cosmic adventure's just getting started. We started by looking for planets like Earth, then expanded to finding places where water might be. Now, we're diving into studying what these faraway planets are made of. With our fancy tech, especially in checking out atmospheres, we're spotting signs that could mean life exists out there. It's like we're on the edge of figuring out this huge space mystery. Life beyond our little blue dot. But don't get too ahead of yourself. This isn't a quick race. It's more like a long marathon. Scientists are working hard to find clues of life on exoplanets, like a space code that might unlock the secrets of other life forms. As our telescopes peek deeper into space, each discovery not only widens our cosmic know-how, but also makes us rethink just how much the universe might be hiding. And guess what? There's even more cosmic excitement waiting around the corner, unveiling Earth's ancient palette of purple bacteria. In a mind-boggling journey back in time to Earth's ancient days, scientists dug into the Archean era, a time buzzing with life, including these mysterious purple bacteria. This era was like a bustling life festival, and researchers wanted to know how these ancient beings might have changed how Earth looked from really far away. To crack this cosmic riddle, they used models and fancy simulations, considering a bunch of things. They focused on how much of these purple bacteria were around and where they lived, whether in water or on land. Plus, they looked at things like clouds and how thick they were back then. What they found when they peeked through the cosmic window was mind-blowing. These purple bacteria are like light magicians. You know how plants here on Earth have this trick where they reflect more near-infrared light, called the red edge effect? Well, these bacteria have their version of that, but in different colors. They do this light trick because of their special pigments that soak in light. And get this special talent helps them grab the light and turn it into energy. And it's not just about Earth, it's about way more. Imagine this. If an exoplanet is covered in these bacteria and has clear skies, fancy telescopes might spot these tiny geniuses. Cue the James Webb Space Telescope, becoming a VIP in unlocking cosmic secrets. But hold on to your space boots, 'cause there's more. The way these ancient bacteria dance with light is like they're speaking their secret language. It's as if they're painting the skies with their unique colors. And this isn't just for Earth. It could happen on other planets too. Picture an exoplanet far away where these bacteria rule, their colorful mark shining under just the right conditions. It's not just a discovery about our past, it's about what might be out there, waiting for us to discover. These findings aren't just a peek into Earth's past. They're a peek into the universe's potential. It's like finding a hidden treasure trove of hints that might help us solve the mysteries of distant worlds. And as our tech gets better, especially with telescopes like the James Webb Space Telescope, it's like unlocking a new chapter in our cosmic storybook. So, as we dig into our history, we're also keeping our eyes on the stars, excited to uncover their secrets. Dark matter and dark energy's silent influence on the celestial stage. Understanding the universe is like unwrapping a complex, intergalactic storybook. Initially, scientists believed that over time, the cosmic show would gradually slow down as gravity's pull took center stage. But plot twist, the universe threw us a curveball, revealing that it's speeding up in its expansion. This unexpected turn in the narrative adds a whole new layer of mystery, beckoning us to delve deeper into this cosmic enigma. In this vast cosmic theater, there's a mysterious duo in the limelight: dark matter and dark energy. Dark matter is like this subtle, hidden essence scattered across space, orchestrating the cosmic performance by quietly holding galaxies and clusters together through an invisible structure. It's like the hidden backbone, comprising about 27% of the whole cosmic tail. Even though it eludes our sight and detection by traditional means like light, scientists can trace its gravitational clues to unravel its pivotal role in the grand cosmic symphony. Enter dark energy, the grand maestro of the cosmic orchestra, claiming a staggering 68% of the cosmic spotlight. This enigmatic energy behaves as the director of this grand play, urging the universe to expand at an accelerated pace. We can't directly observe it, but we perceive its impact by studying the dance of galaxies and their arrangements, a sort of cosmic choreography that unveils its cryptic influence. While it's elusive, dark energy leaves its mark on the cosmic stage through meticulous measurements of elements like background radiation and the overall structure of the universe. It's like a cosmic mystery novel where these hidden characters, dark matter and dark energy, play crucial roles behind the scenes, shaping the narrative of our cosmic tale. Understanding their nuances unlocks not just the secrets of our universe's past, but also the trajectory of its future. For the longest time, dark matter and dark energy were akin to fascinating whispers in the vast expanse of space. But now, there's a potential shift in how we perceive the cosmic canvas. Typically, stars, like our brilliant sun, derive their energy from nuclear fusion within their cores. This process fuses lighter elements, such as hydrogen, into heavier ones like helium, birthing both the building blocks of stars and the radiant energy that illuminates the universe. There's this new idea floating around about stars and their energy source. It's called dark matter. Dark matter might not just be hanging around in space. It could be self-destructing and releasing a bunch of heat, basically feeding the brightness of stars. This flips our understanding of how stars shine. It's like saying the cosmic dance isn't just about nuclear fusion. It's also about this mysterious energy hiding within dark matter. Wild, right? Now imagine what else the James Webb Space Telescope could stumble upon as it peeks into the universe with its lens. It's like diving into a treasure trove of cosmic secrets, waiting for explorers like us to figure out the universe's mysterious story. It's an exhilarating time for cosmic discoveries. Cosmic giants, fueled by the secrets of dark matter. The James Webb Space Telescope is like a cosmic storyteller, capturing these ancient tales from the universe. And among its discoveries are these stars with some interesting code names: JWST, Z11, Z12, and Z33. But hold on to your cosmic hats, because Z12 and Z33 steal the show. These aren't your run-of-the-mill stars. They're labeled as dark stars in the space drama. But fear not, they're not spooky. Instead, they're possibly fueled by something elusive: dark matter, the mysterious force that conducts the cosmic orchestra. Now, these dark stars are no lightweights. They shine billions of times brighter than the sun and are millions of times heavier. Talk about a cosmic heavyweight showdown. But here's where it gets really interesting. Scientists are pondering how these mysterious stars came to be. The leading theory? They might have emerged not long after the Big Bang. Imagine this. In dark matter-filled zones, clouds of hydrogen and helium collapsed under gravity's pull, giving rise to these cosmic wonders. It's like putting together a huge cosmic puzzle. These dark stars are like rebel stars, doing their own thing, maybe dancing to the tunes of dark matter itself. It's a mix of mind-boggling and incredibly captivating, isn't it? The universe sure knows how to keep us on our toes. Supersymmetry's explosive energy cascade. Let's dive into the cosmic concept of supersymmetry, a theory that proposes a fascinating idea: dark matter particles having cosmic twins called superpartners. Picture the early universe as a celestial kitchen where these dark stars start their cosmic cooking. It all begins with clouds of helium and hydrogen, remnants from the ancient explosion, coming together in a celestial dance. And trust me, the way the universe operates gets seriously interesting from here on out. When dark matter particles have these superpartners, according to supersymmetry, they start engaging in a cosmic tango in space. This dance leads to a collision, a bit like matter meeting antimatter, creating an explosive burst of energy. Now, this energy cascade is no ordinary affair. It gives birth to a whole new set of particles: photons, electron-positron pairs, and those elusive cosmic ghosts called neutrinos. Neutrinos are the ultimate escape artists, slipping away quietly, while the other newly formed particles hang around. These particles then share their energy with the hydrogen and helium in the cloud. It's like a spark igniting an engine, warming up the cloud and setting the stage for the birth of dark stars. Unlike your regular stars, powered by nuclear fusion and shining intensely, these dark stars play it amazingly. They emit less intense light, which allows them to maintain their chill for incredibly long periods and grow to massive sizes. These dark stars might hit temperatures similar to our sun's surface, but shine as brightly as entire galaxies filled with ordinary stars. They're cosmic giants in their unique way. And here's the mind-bending part. This additional information about the Big Bang might just surprise you. It's like finding an extra chapter in an ancient cosmic book, unraveling more secrets about our universe's beginnings. Who knows what other surprises are waiting to be discovered in the vast expanse of space? That's the beauty of cosmic exploration. Every discovery leads to more questions and, of course, more mind-boggling revelations. Cosmic ballet of amplification. Around 200 million years post-Big Bang, a cosmic drama unfolded starring something called mini-halos. These weren't your typical galaxies. They were tiny cosmic cradles, mostly crafted from dark matter. In the early universe, when the cosmic recipe only boasted simple ingredients like helium and hydrogen, these mini-halos stole the celestial spotlight. Now, in this early cosmic theater, these mini-halos set the perfect scene for a show we hadn't witnessed until our telescopes caught up with the cosmic drama. Back then, heavy elements hadn't yet joined the cosmic party, creating just the right conditions for the emergence of something spectacular: dark stars. They were the cosmic newborns born within these mini-halos, a phenomenon that remained hidden for eons because, well, our technology was playing catch-up with the vastness of cosmic history. Imagine the universe staging this incredible performance, but our tools weren't quite up to speed to capture it. The revelation of this cosmic secret was waiting patiently for a cosmic guardian to arrive: the James Webb Space Telescope. It's like the universe had this incredible tale to tell, a story of cosmic births and celestial nurseries, but the spotlight wasn't shining bright enough until the arrival of our cosmic detective, the James Webb Space Telescope. And when it finally arrived on the scene, it unveiled this hidden chapter in the cosmic saga. The James Webb Space Telescope is like a time-traveling wizard for scientists. It peeks into the deepest part of the universe, and when it stumbled upon those dark stars roaming freely in their cosmic halos, it rewrote the whole story of how we view the universe. But how did this telescope crack the code of this cosmic riddle? Imagine gravitational lensing as a majestic space ballet. Picture this: a colossal galaxy, gracefully gliding in front of a far-off star or galaxy. This cosmic performer's gravity acts like a lens, bending the path of light. It's like an optical illusion, making things appear larger and twisted, but without actually changing how far away they are. It's a mind-blowing show that the telescope picks up, making distant things look closer or bigger. Now, here's where the cosmic detective work got tricky. These objects were so far away that figuring out their true nature was like solving a galactic mystery. At first, they were labeled as possible galaxies, but with some serious computer sleuthing, it started to seem like 3 out of the 4 might just be these elusive dark stars. If that pans out, discovering dark stars in these tiny pockets of space could solve not just 1, but 3 cosmic head-scratchers. First off, it might explain why the JWST spotted so many gigantic galaxies in the early universe, which flips what we believed before. Then, there's the mystery of those massive black holes that appeared early in the universe. They were too colossal to be born from regular stars. Enter dark stars. They might hold the key to understanding where these cosmic behemoths came from. But hold on to your space helmets, because here's the real kicker. Dark stars could be the smoking gun proving that those elusive particles of dark matter are for real. And not just that. They could also show us how these particles do more than just tug on stuff with gravity. They might have a whole other side to their cosmic dance. And trust us, this is just the tip of the intergalactic iceberg. JWST's gaze into luminous celestial anomalies. The JWST, with its vigilant gaze, has stumbled upon galaxies that defy the norms. These galactic oddities, appearing surprisingly large for their youthful age, throw a curveball at what we thought we knew about the early universe. Traditionally, we expected smaller galaxies to take center stage first, gradually growing over time. But hold on, because these distant giants are challenging that script. What if, instead of being your run-of-the-mill stars, these colossal entities are dark stars, wrapped in an enigma, potentially holding the key to their rapid growth? It's like a cosmic dance, choreographed by the mysterious movements of dark matter, allowing these dark stars to balloon to massive sizes in the blink of an eye. Imagine the intrigue of a story where the cosmic plot thickens, and dark matter and energy swirl together, unveiling the mystery behind the abundance of massive galaxies in the early universe. Now let's venture even farther into the cosmic expanse, where we encounter celestial wonders with names like Mothra and Godzilla. These aren't your average stars. They're the cosmic kaiju stars, defying expectations and shining their brilliance from more than 10 billion light-years away. Meet Mothra, a double giant that puts on a celestial spectacle. Picture one giant radiating light like 50,000 suns, while its partner blazes with a brilliance that's a staggering 125,000 times brighter than our own sun. And then there's Godzilla, standing out as the brightest star ever discovered. But here's the twist. Its luminosity goes beyond the explanation of gravitational lensing from a distant galaxy cluster. Something elusive lurks in the shadows. Scientists, driven by an insatiable curiosity, estimate Godzilla's mass to be a mind-boggling 10,000 to 2,500,000 times that of our trusty sun. But that's not the end of the discoveries. Exploring the secrets of Proxima Centauri's realm. Out there in space, there's this planet called Proxima Centauri b, just hanging around its star, Proxima Centauri, not too far, only about 4.2 light-years from Earth. It's like this mysterious world that makes us wonder, is it anything like our own planet? Could it have oceans and tons of creatures living on it? And get this, it's not alone out there. It's got a buddy planet called Proxima Centauri c that it hangs out with. Proxima Centauri b gets a similar amount of energy from its star as Earth does from the sun. So scientists are all hyped about whether there could be water or even life on this far-off planet. As we're cruising through space, we bump into all sorts of these other planets, called exoplanets. They're like worlds that circle stars that aren't our sun. And guess what? There are a crazy number of stars out there. 206 trillion of them spread across the universe. That means there could be endless possibilities for these exoplanets. Some of them are like space wanderers, just roaming around without a star to call their own. Kinda like cosmic nomads, you know? Proxima Centauri b is like this tricky riddle in the middle of a huge cluster of stars. Its year is short, just 11.2 days in Earth time, and it circles its star crazy close, like 20 times nearer than Earth does to the sun. That means one side is always bright as day, while the other is stuck in constant darkness, adding to its mystery and maybe its awesomeness too. Scientists found Proxima b using this groundbreaking way called the radial velocity method. It's all about watching how a star moves because of the pull from a planet. As the planet goes around, it makes the star wobble a bit. And clever astronomers spot this by checking changes in the star's light, something called the Doppler shift. This tiny dance in the star's light helped us find Proxima b, proving how interesting the radial velocity method is for discovering planets beyond our solar system. And it's a big deal because it confirmed there's a planet around the nearest star to our sun that could maybe support life. That got scientists and space fans everywhere excited. They're all dying to figure out what secrets Proxima b might hold and what it means for life beyond Earth. Proxima Centauri b is part of this awesome trio, Regal Centaurus, Ptolemy, and Proxima Centauri, dancing in space, making up the closest star system to us. When you look up at night, Regal Centaurus and Ptolemy shine bright in the Centaurus constellation. But it's Proxima Centauri, the little guy in the group, that's got something intriguing going on. Also called Alpha Centauri c, this red dwarf star is just 0.21 light-years away from its brighter buddies. To put that in perspective, it's like 13,000 times farther than Earth is from the Sun. Its name, Proxima Centauri, basically means closest star in Centaurus, in fancy Latin. Back in 1915, an astronomer named Robert Thorburn Ayton Innes introduced this cosmic gem to the world. But here's the thing, it's so close, yet we can't see it without a telescope. It's way too faint for our eyes, shining at an apparent magnitude of 11.13 when the human limit is about 6.5. Still, it's a star worth noticing. Hopeful expectations, and realistic hurdles for life. Red dwarfs like Proxima Centauri might look small, but they're mighty powerful, making energy in their cores. This star is going to keep doing its thing as a main sequence star for about 4 trillion years, shining through the ages. But hold up, the idea of life around Proxima Centauri has its hurdles. This star throws these random bursts of energy, being a flare star and all. Because it's smaller, any chance for a habitable zone where life could live is way closer to the star compared to where Earth sits in our Sun zone. Enter Proxima b, roaming in this zone, seemingly like Earth's spot around the Sun. But don't be fooled. This planet deals with strong ultraviolet rays, hundreds of times more intense than what Earth gets. That kind of radiation messes with substances like hydrogen molecules, making life's basics like nitrogen and oxygen unstable. Plus, just being in this Goldilocks zone doesn't guarantee a comfy place for life. Proxima b might not have the right atmosphere to keep things steady, for life to thrive, manage its climate, or keep water around. Tough break, right? The absence of a tough-as-nails atmosphere on Proxima b means any potential life there would have a rough time dealing with space's wild weather. It's a big hurdle for life as we know it. But hey, scientists aren't giving up. They're still hyped about digging into Proxima b's secrets. And guess what's stealing the spotlight in this cosmic quest? The James Webb telescope. This top-notch gadget finally took off at the end of 2021 after some delays. This telescope's the key to unlocking one of astronomy's biggest mysteries. Is there life on Proxima b? But hold on. Getting the truth about Proxima b isn't a piece of cake. The James Webb telescope had to get some serious upgrades to snap precise images. According to A.V. Loeb, a hotshot physicist from Harvard, cracking the Proxima b code needs a smart approach. See, Proxima b's in this special zone around its star where it might soak up and shoot out light as infrared radiation. And lucky for us, the James Webb telescope can catch that infrared glow from the planet's surface. It's like a spy gadget helping scientists hunt for signs of water or an atmosphere. And let me tell you, water's a game changer. If Proxima b's got water like Earth does, it's a big deal. Water's important for life here, so finding it there would boost the chances of the planet being friendly for life, or at least able to support something living. Now, Proxima b gets about the same amount of solar energy as Earth does from the Sun, but because it's cozying up to its red dwarf star, it gets hit hard by radiation and magnetic action. That could mess up any potential atmosphere and the chances of having liquid water. Right now, scientists are using fancy computer models and simulations to guess what Proxima b's weather might be like and where water might hang out. Some ideas say there might be giant oceans there, while others think any water might be frozen or hiding underground. But spotting water directly on Proxima b, that's a tough one. It needs top-notch telescopes and just the right air conditions. As our telescopes get better, we're slowly uncovering Proxima B's secrets about its air and maybe water, getting closer to understanding this exoplanet. But having an atmosphere isn't a guarantee Proxima B's a nice place for life. Ed Turner from Princeton University warns us not to jump to conclusions just because there's an atmosphere. It might turn out more like Venus, all thick and sweltering, definitely not friendly for life as we know it. Proxima B's not just another far-off planet. It's like that interesting neighbor in our space hood, making us wonder if it's got what it takes for life to hang out there. It's so close to Earth that it's got astronomers and space fans all excited for future missions. But let's be real, going to Proxima B, that's a mega challenge. Using current spaceships like Voyager 2, it'd take a mind-blowing 73,000 years. But humans are dreamers and inventors. And we've got some ideas, like solar sails. These thin sails might change space travel, zooming spacecraft crazy fast. With them, we could hit up the Proxima Centauri system in just 2 decades. Imagine exploring an Earth-like planet in our lifetime. Sounds amazing, right? The discovery of Proxima B has sparked our love for space all over again, giving us hope and a serious case of curiosity. It shows how we're always pushing to explore new places, wondering if there's life beyond our home turf. What implications do you foresee if life is confirmed to exist millions of light years away from Earth? Share your thoughts in the comments.